So x plus 2 over x and x times 2 over x. This is a very simple problem. If you need to think about this on the test, make a really simple problem. In both these, people might be tempted to cancel x. Because like, oh, x over x, I can cancel it. Problem is I can only cancel factors. So these aren't factors. The x plus 2, those are terms, whereas the x times 2 is factors. And if you think about it, what's if x equals 10? If x equals 10, this one is going to be 12 tenths, whereas this one over here is going to be 20 tenths. If I cancel, oh, that's still 2. That doesn't change. But if I cancel over here, that is no longer the same thing. 12 over 10 is not the same as 2. So this is why you can't cancel that one. You have to leave it as x plus 2 over x. So it's really important. You only want to cancel when you've got factors. Think about things like, so if those two factors with a multiplication in between them are the same, I can cancel them. But if there's a plus in between two things, I can't cancel next to a plus. So that's kind of the most common thing, because it's really easy to accidentally do that. And if you, from that thing I gave you last week, one of the answers on the multiple choice was you making this mistake. So you've got to not make that mistake. On the other page here, just really quickly, one thing I want to point about that, obviously you've got to factor all that for this to make sense. One thing we haven't spent a lot of time going over is when you've got a common factor. It's helpful if those all have a 3 in them, is to bring that 3 out front and rewrite it that way, and then you've got something that's much easier to factor. You can actually factor the way it is, but it's going to have some stuff in there. All right. Now, this is the point where some of you can probably do this in your head, and some of you might need to do the little area model to do that. So for the top one, x squared plus 7x plus 10, I want something, I get an x squared there, so I'm going to get an x and an x, and I'm going to get a 10 there, and I want those two things to add to 7. So what are my factors? 2 and 5. In this case, it's somewhat obvious. I don't have to worry about signs, so it's 2 and 5. So I got 3, x plus 2, x plus 5, and then what's the bottom one factor to? What was it? 4 and 2. Okay. And in this case, I'm probably expecting to get something to cancel. If I don't get something that cancels, I'm going to go back and look at my work. Because most times when you get a problem like this, something's going to cancel. So those will cancel, and this is my simplified form. And then there's this whole series of questions, which if you look at the next page, which I'm going to jump over that. This you can go back and look at the online version. If you jump to the next page, you basically have to ask yourself all those questions to answer this. I mean, you can certainly do it in your calculator, but you have to answer this to do this. And I want to go through. I'm gonna go through the middle one here. There's kind of a trick to this one, but we can talk about it tomorrow. So the top one, I got 3 and x minus 4, because I can bring a common factor out, and the bottom one, I'm hoping it's going to be x minus 4 and x plus 6. Now that worked out perfectly. I was worried my minus and plus would be backwards, but so I got the x minus 4s will cancel out. Okay, for that one right there, where are my holes? Anybody know where the hole is going to be? Thanks. If we go back and look at the front, how do we figure out our holes? The way we figure out the holes, what value of x makes both the numerator and denominator equal to 0? Those are the things that you cancel. So if we go back and look at this, we're like, oh, x minus 4 and x minus 4 canceled. 4 makes a hole there. That's the x value. And then if you needed the y value, you'd plug the 4 back into my reduced version there. So my reduced version there is 3x plus 6. If I needed to know the y value, I would just plug in the 4 right there. I think on the answer sheet it only shows x equals 4. In fact, let me double check that. Yeah. Vertical asymptotes. Anybody know where the vertical asymptote is going to be for that one? That's the easy one. It's going to be a hard exam. It's going to be -6. It's the other thing. It's like, well, this didn't cancel, but it causes a 0 here, which is what it says back here. It says what value of x makes the denominator 0? This is in the reduced form. So we already took care of our whole, so that one's going to be a negative 6. Now, if I graph this, I will see that too. If I actually plug in the original equation into my calculator, remembering when I plug it in the calculator, make sure you put parentheses around that, otherwise it's going to do something weird. You could verify that, oh yeah, it looks like it's going to not cross negative 6. Once again, the asymptotes is where it's going to look like that's what we're looking for. The horizontal asymptote. Now, the long way we did it was we did long division, which I'm not going to go over again. If you want to go back and do long division and look over some of your notes how to do it, this reasoning method on the front works pretty well. It says what happens as x approaches infinity or negative infinity, or more importantly, just think about, like, if I plug in a very big number for x, what happens to y? So if we go back and look at our example over here, I got 3 over x plus 6. If I plug in like a million, what is that essentially? 3 over a million. What's it super close to? Or 3 over a billion, or 3 over a Google. It's getting closer and closer to what? Not getting closer and closer to 3. It's something over a super large number, so it's really close to what? It's really close to 0. Okay? So 3 over a billion is basically 0, so my horizontal asymptote is y equals 0. So that would be here. This thing hasn't shifted up or down at all, which is the other way I can tell. And then the x and y intercepts, once again, I could verify over there, but my x-intercept, looking back at the front, my x-intercept is what would make y equals 0, where the y-intercept is what would make x equals 0, or just plug in x equals 0. So for this, I need to know 0 equals 3 over x plus 6. Am I doing that right? Let me reread my note here. Y equals 0. Is there any value that's going to make x equals 0? That I can put in there that will make y equals 0? It looks like maybe negative 6, but that's undefined because that's our asymptote. This one actually doesn't have an x-intercept because it never crosses. It actually, that's my asymptote right there, which means it never crosses. Okay? So in some case, I might not have an x-intercept. And then the y-intercept is simply same thing. I'm like, well, okay, y equals 3 over 0 plus 6. And I'm like, oh, that's 1/2. Or 3 over 6, or 1/2. Okay? So my y-intercept is 1/2, or I can write it as 0, 1/2. Getting a little messy here. Well, this one was a none. And then finally, the simplified equation we already took care of. Probably should, I don't like the way this is ordered. I would actually ask that second. And then we go over and graph it. So we can do it with a calculator. We definitely would want to do it with a calculator to verify, but just going through what's here, I'm like, okay, I got an asymptote at negative 6, which is 1, 2, 3, 4, 5, 6. So I got a line there that it's not going to cross. I got a line here that's not going to cross. This thing is going to go through, oh, it's been dilated by 3, so it's going to be up 3. That's one thing that's not in here. This right here, this is a dilation. Normally this would be up 1, but it's up 3 and over 3. And then down here, instead of being 1 away, it's 3 away and 3 away. And I'm getting that both because I just cheated and looked at the answers, but also because I'm like, oh yeah, that's how you remember that. That's our dilation factor there is 3. So instead of being at 1, 1, it's at 3 away and 3 away. And then I got a hole at 4. So out here at positive 4, right there, I should make it obvious that I got a hole. All right. Oh, domain and range. Is there any x value, because domain is x's, is there any x value that x can't be? X is all real numbers except what? It can't be negative 6. It's never going to cross the negative 6. And what else is it not going to go through? my whole, okay? So it's not equal to negative 6 or 4. And that's actually, I'm just noticing on the key online, whoever did the key didn't fill that in. And then my range, everything up or down except for the y-intercept. So y is anything except it can't be can't be the 0 there. And it also can't be the whole, which means I've got to plug back in over here to figure that out. This is where I have to plug back in. That's going to be 3 over 4 plus 6, or 3/10. Because I'm plugging in for the whole. All right. So that's a little bit of everything. We can spend some more time practicing this more. I think this is because it's the oldest stuff. It's going to be kind of the hardest to remember. The main thing is you can lean on your calculator for a lot of this stuff, but you do need to be able to explain like how you got the answer. All right. So in having